Good day, this is the Professopher, drwillphd, PhD, and today's Saturday, December 17th, 2022. It is 1:58 and 50 seconds, a.m. Eastern Standard Time, and today's research, Nanolasers. So let's jump to it here. Researchers develop all-optical approach to pumping chip-based nanolasers. New technology could aid in meeting the ever-growing need to move more data faster. Date December 15, 2022. Source: Optica. The scientific researchers have developed a new optical method for driving multiple, highly dense nanolaser arrays. As described in Optica, the approach can enable chip-based optical communication links that process and move data faster than today's electronic-based devices. The development of optical interconnects equipped with high-density nanolasers would improve information processing in the data centers that move information across the internet. And this could allow streaming of ultra-high-definition movies, enable larger-scale, interactive online encounters and games, accelerate the expansion of the Internet of Things, and provide fast connectivity needed for big data analytics. Researchers demonstrate that densely integrated nanolaser arrays, in which the lasers are just 18 microns apart, can be fully driven and programmed with light from a single optical fiber. Optical devices integrated onto a chip are a promising alternative to electronic integrated devices, which are struggling to keep up with today's data processing demands. And by eliminating the large and complex electrodes typically used to drive laser arrays, we reduce the overall dimensions of the laser array while also eliminating the heat generation and processing delays that come with electrode-based drivers. The new nanolasers could be used in optical integrated circuit systems which detect, generate, transmit, and process information on a microchip via light. Instead of the fine copper wires used in electronic chips, optical circuits use optical waveguides which allow much higher bandwidths while generating less heat. However, because the size of optical integrated circuits is quickly reaching into the nanometer regime, there is a need for new ways to drive and control the nano-sized light sources efficiently. And to emit light, lasers need to be supplied with energy in a process called pumping for nanolaser arrays. This is typically accomplished using a pair of electrodes for each laser within an array, which requires significant on-chip space and energy consumption, while also causing processing delays. And to overcome this critical limitation, the researchers replace these electrodes with a unique optical driver that creates programmable patterns of light via interference. This pump light travels through an optical fiber onto which nanolasers are printed. And to demonstrate this approach, the researchers use a high-resolution transfer printing technique to fabricate multiple photonic crystal nanolasers spaced 18 microns apart. And these arrays were applied onto the surface of a 2-micron diameter optical microfiber. This had to be done in a way that precisely aligned the nanolaser arrays with the interference pattern. The researchers say the interference pattern can also be modified by adjusting the driving beam's polarization and pulse width. The experiment showed that the design allowed multiple nanolaser arrays to be driven using light traveling through a single fiber. The results match well with numerical calculations and showed that the printed nanolaser arrays could be fully controlled by the pump beam interference patterns. The all-optical laser driving and programmable technology can also be applied to chip-based silicon photonic systems, which can play a key role in the development of chip-to-chip or on-chip optical interconnects. However, it would be necessary to prove how independently the modes of a silicon waveguide can be controlled. If this can be done, it would be a huge leap forward in the advancement of on-chip optical interconnects and optical integrated circuits. And this is the Professopher of Space Technology, Advanced Physics, and Mathematics. Well, this video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.